I'll say right now that I will do them, but after the lesson. Anybody?
Yeah, I had 2.
Stop fighting.
Yeah, I had 1.
Okay, so which questions?
2G.
2 A, B, C, D, F, G. 2G,
G.
so that's approved. Okay, 2G, yeah. And Karina, did you say something?
Yeah, 3C and 3H.
3. Okay, 3C and what was the other one? Sorry?
3H.
3C and H. A, B, C, D, F, G, H. Okay, cool. All right, I'll do those at the end of the lesson. All right, so sum and difference identities. Way less notes today. You don't have to copy these ones down. These are the new identities, though. I fully admit this looks terrible the way they're just put there. Like the curbside appeal here is gross, but you know what? I teach math. I'm not an interior designer. They look crazy, but they're not. The big thing here, this just means 2 different angles. So one might be 45 degrees, one might be 15, whatever. They're just 2 different angles, and how to deal with them breaks down in these 6 different ways. So that's what that is. Just to be clear right off the hop, if you see this, like sine of A plus B, that does not equal sine of A plus sine of B. You cannot just make that conclusion. That does not work. If you are copying these down, that's totally fine, but just let me know so I don't speed along. Or better yet, just tell me when you're done writing, please. No rush.
I'm done.
Thank you.
I'm done.
Done.
All right, so I also wanted to say, oh, hello, welcome, whoever just joined us. I did want to say when it says identities can be used to simplify and solve. So you might, for example, be given a question, solve for the sine of 15 degrees. And you might, and it might say like, no calculator, what is the exact value? By the way, when something says exact value, that means it's not a kind of a decimal that's been rounded. It might include a root sign. Like the exact value of the sine of 30 degrees is, or sorry, the sine of 60 degrees is root 3 over 2. That's the exact value. If you punch that into your calculator, you'll get, I have no idea what you'll get, 0.764823, whatever. That decimal is not the exact value. So you might be asked, like I said, to get the exact value of 15 degrees, which means you could use this formula here. So that would be the sine of 45, or sorry, not this one. Like here, the sine of 45 minus 30, because that is the sine of 15 degrees, and then this will help you figure it out. And you'll see. I'm trying to explain some stuff before we actually get to it, but you will see it. Those folks that who just joined, can somebody tell me, because I don't want to change the screen. Oh wait, no, I can figure it out this way. No, just tell me. Who? Sorry?
Me. Matthew.
Matthew, and there's another one. And Gavin. Okay, Matthew and Gavin, tell me when you're done copying this down, please. You don't need to copy this white stuff, these things. Can you guys, I know you can see my screen. Can you see this up here? Like right now it's got Gavin in the screen. Can you guys see this or no?
No.
No.
Oh, okay, so I can I can just pop that down. You know, Matthew, honestly, every time I see your avatar or whatever you want to call it, I know it's the Winter Soldier or whatever, but I honestly, the first thing I think of is Evan Giesbrecht. Anybody else see that? Is it just me? Okay, never mind. Anyways, Matthew and Gavin, please tell me when you're done copying the notes.
Who's
I'm
Evan
done.
Richt?
He's grade 11. Grade 11 guy.
Oh.
That looks like the Winter Soldier, apparently. Gavin, you said you were done?
Yeah.
Matthew, you done?
Almost.
Okay, no rush. I just didn't know if I missed you saying. Although I think we just added somebody. Would it be better if I started the class at 9:06? I just did 9 because it was a round number. Would it be better to do 9:06? Future days?
Sure.
Okay, I will. For what it's worth, physics, for two of you guys, I did it for 11:30 for today.
I'm done.
Thank you. Emma, you just need these top points. You don't need to copy down the
Okay.
whatever.
Yeah, I'm good to move to
You
the
good?
next one.
Okay, thank you. Okay, and that's it. That's the only one. So we're gonna get to no, not me. Examples. Cha-ching. Now I'm going to I'll change this just so I can see what I'm doing better. I want to use a pen instead of the marker because the marker takes up so much space. So if you have a problem seeing it, please say so. I don't mind changing to the marker. It's just I think it'll be neater. But if you can't see it, then it's no good. So let me write down the first question. Oh, I kind of already said it. So example 1, page 204. There's a mess underneath example 1, but can you see this okay? Like, do you think I'll be able to do it with pen?
Yeah.
Yep.
Okay, the moment something doesn't make sense or isn't clear, please let me know. So it says find the exact value of sine of 15 degrees. So if you see this, sine of 15, the exact value, meaning no calculator. Again, this is all brand new, so you might be like, what in the world do I do? You need to set up something that kind of finds sine of 15. I'm not explaining this super well. But if you look at the one proof, if we look at sine of the way it's written in the book I gave you, alpha minus beta equals sine of alpha cos of beta minus cos of alpha sine of beta. I'm just going to make sure I copied this down right. Sine of A minus B, sine of A cos of B minus cos of A sine of B. Okay, so now what we can do, sine of 15, we don't know that, but we know the sine of 60 and we know the sine of 45. And we know the cos of 60 and the cos of 45. So if I rewrite this as sine of 60 minus 45, and then rewrite it, so this is for all the kind of the A's, this is all the B's. Sine of 60 times the cos of 45 minus the cos of 60 times the sine of 45. We can plug in these numbers. We know these numbers. These are our kind of unit circle numbers, which is why we spent time on the unit circle and nailing it down. And you might not know these off the top of your head. That'll come with more practice. But worst case scenario, you have a unit circle, you fill it out, just at least the parts you need. This is just kind of top right quadrant. And then you can go from there. But what that is, so the sine of 60 is root 3 over 2. Cos of 45 is root 2 over 2. Minus cos of 60 is a half. And then the sine of 45 is root 2 over 2. I'm going to pause there and see if I'm losing anybody. Let you take it down and see if I've messed with anyone.
So did you get the 60 and the 45 because they were in like the same quadrant and then the difference is 15?
Yes. Yes.
Okay.
I just tried to think of the simplest way to do 15 was 60 minus 45.
Okay.
And we don't know, off the top of our heads what sine of 15 is. These ones we can, if we don't know off the top of our head, we can figure it out in a few moments. This would be much more difficult. So this, then you just simplify. Root 3 times root 2, excuse me, is root 6 over 4, minus 1 times root 2 is root 2 over 4. Same denominator. Root 6 minus root 2 over 4. That is the answer. It looks weird. And you're thinking, like, that can't possibly. It is. This is an exact number. This is not a decimal that we're rounding or anything like this. This is as exact as it comes. If you were to convert this to a decimal, I think the textbook does 0.2588190451. Like, it goes on forever, and you have to round it eventually. And also when it's doing the decimal, the textbook shows these kind of squiggly equal signs, 0.258, blah, blah, whatever. And it does this because it's not exact. If the decimal ended, let's say you punch this into your calculator and it came out to exactly 0.258, then that would be an exact answer. But as soon as you got a round somewhere, you're not exact anymore. Any problems? Is anybody not ready for me to move on to the next one? Okay. And can you guys see the pen okay? This is okay?
Yeah.
All right.
Yeah.
Okay, let me know again. The moment something doesn't make sense or is hard to see, please let me know. Okay, example 2. If cos, okay, I'll just write it down. So it says cos of theta equals negative 2 over 3. Theta is in quadrant 2. Find, oh, here we go. I was like, where's this going? Find cos of theta plus pi over 3. Pi over 3 is like cos of pi over 3 is something that we know, or at least can find with the unit circle. It's telling us that cos of theta, just itself there, is negative 2 over 3, so we can just substitute that in. The reason it's telling you, I think, I haven't done this, the reason it's telling you that theta is in the second quadrant is that it tells us that the cos is negative, but the sine will be positive. Because we're probably going to have to do the sine of pi over 3, so we know it's going to be positive. So anyways, find this. So let's cos of theta plus pi over 3. There's so much noise in my hallway. I don't know. It's weird. It's not even like this during regular school. Cos of theta plus pi over 3. So we've got to find the identity that works. Cos of a plus b. Put it on my board here. It's hard to see. Cos of a plus b equals cos a cos b. So this is cos of theta, cos of pi over 3, and then minus sine a sine b, minus sine theta sine pi over 3. Now, the first thing that we need to do, we need to take a little kind of pause from this action because we have no idea what to put in for sine of theta. Cos of theta, negative 2/3. This is negative 2/3 pi over 3. That's 60 degrees. So this is a half. This is root 3 over 2. This we have no idea. But what we learned from last test, maybe I'll do it in a different color just to show we're doing something a little bit different. Cos of theta is x over r. which is negative 2 over 3. So if we need to solve for what y is, or what sine of theta is. So if this is our radius, 3 squared minus negative 2 squared equals y squared. 9 minus 4 equals y squared. So the root of 5 equals y. Therefore, sine of theta equals the root of 5 over 3. And this was this like the last question on the last test? Or I don't know for sure, but there's a question like this. And so that's how we go about finding this. Quadrant 2, that's why it's positive. If we were told it was 3 or 4, it would be negative for sine. After this, we just do some substitutions. Is everybody okay with this?
Yep.
I gotta go shut my office door. I don't know. Is there a party? Am I missing a meeting? I don't know what's going on. Super weird. Okay, so I'm continuing on. Now I'm focused on this here. Cos of theta is negative 2 over 3. Cos of pi over 3 is 60 degrees, which is a bigger angle. The cos is shorter, so that's a half. Minus sine of theta, we now know is root 5 over 3. And sine of pi over 3, again, big angle, so it's root 3 over 2. Can you guys see how I'm doing this stuff in my head, like cos of pi over 3 and sine of pi over 3? Do you need a little visual?
I understand it.
Maybe once in a while.
Okay, so here. So if this is a unit circle, pretend that's a perfect circle. Halfway around is pi. Okay, so pi over 3 is a third of that. And this is also 180 degrees. So this tells me that this is 60 degrees. So go 60, 120, 180. So this is the 60 degree angle, which means this is root 3 over 2, and this is a half. The shorter one, like this version, it would be 30 degrees, or pi over 6. And then so that the y value here would be a half, the x value here would be root 3 over 2. And this is the stuff I'm doing in my head. And not because I'm smarter than anybody here, but because I've taught this a whole bunch of times. And it's a familiarity thing, which is why I have you guys messing with unit circles so much. So what you might need to do, pi over 3 is draw the unit circle and then just kind of, oh yeah, okay, that's where this goes, blah, blah, blah. And I'll give you that template to draw the unit circle instead of forgetting like I did last time. I hope I don't forget. Does that help, Karina?
Yes, that's good.
Cool. And so then this is just academic from here. Negative 2 over 6 minus root 15 over 6. So that's negative 2 minus root 15 over 6. Such a pretty number. Another way of writing it is if you have the negative kind of beside the fraction and then just do 2 plus root 15 over 6. So just be really clear where this is, because that negative means it changes everything. Or you could write it like this. This to me is clearer, but it's up to you. Just make it clear. Just don't be super lazy with your negative signs. Cool.
Cool.
Anybody need more time? No?
For the negative 2 over 3, were you not supposed to find the cos of that? How does that work?
Because it's telling us that this cos of theta equals negative 2 over 3, so we can just interchange. Where it says cos of theta, we can put negative 2 over 3.
Okay.
That make sense?
Yeah.
Good question. It does. I know why you're asking, because sometimes we're thinking, oh, is that what theta equals? Do I need to inverse cos, blah, blah? No, we're just told cos of theta equals that. So it's just a straight substitution. It's a good question.
Okay.
Anybody else? Alrighty. Numero 3. This chord. Okay. Number 3. Look at it, presses through. I don't know if you guys can see that. I guess because of the dark ink. Weird. Anyways. Where's number 3? Oh, we have a proof. Cos. Lost my spot. Of 270 minus theta equals negative sine of theta. Okay, so now for a proof, we keep the left side on its own, the right side on its own. We have to make this side equal this or this equal that. This is the more complicated one, so this is the one I want to mess with. I'm going to leave this for now. It might just be that this is what we come to. So we have cos basically of a minus b. So we're going to substitute this for cos of a minus b. Where is it? A minus b. Oh, so it's cos a, cos b. So cos 270, cos theta, cos of a minus b, plus sine a sine b, plus sine 270, sine of theta. So now, using our unit circle knowledge, we can simplify cos of 70 and sine of 270. And oh, that was beautiful. And I'll show you my thoughts here. 270 degrees. This is 90. This is 180. This is 270 degrees. So the cos, so like this is it right here. Cos is 0. Y is negative 1. Cos of 270 is 0. Sine of 270 is negative 1. So 270, we're going to put in 0. Sine of 270, we're putting in negative 1. It's that straightforward. So cos of 270 is 0, so that's just going to crush also the cos theta. So I'll just write it out though. 0 times cos of theta plus sine of 270 negative 1 plus negative 1 times sine of theta equals, and we have on our right side negative sine of theta. Well, there it is. It's done. 0 times that crushes it, negative 1, so that's negative sine of theta equals negative sine of theta. Now that I shut my office door, I can still hear them, but it's also getting very warm in here. So basically, your teacher is a big whiny baby who's never happy. Did I mention I'm balding? Any problems with this? Any questions?
Just like right at the beginning when we're given cos 270 minus theta, and then from that to the cos 270 cos theta plus the sine 270 sine theta.
How did I do that?
Yeah.
So this formula sheet is what you'll be given. This is what you'll be given for the test. Right now, we are looking at this chunk. We have these new identities, if you will. Come on, camera, don't fail me. So this one, sorry, it was cos 270 minus. So it was cos A minus B. It was cos 270 minus theta, so I just substituted this.
Oh, okay, yeah.
Does that make sense? That's what so much of the identity stuff is substitutions. Put this back on my wall. Is that good, Gavin?
Yeah.
Anybody else? Those of you that are good can go. I know I had a couple questions. I'm going to do those now. And then we had a couple people come like a little bit after I think I asked for the questions. If you want questions, then hang around. I'm going to be doing 2G, 3C, and 3H. Does anybody want to add to that? Those of you without questions don't feel the need to hang around any longer. You totally can, but you don't have to. Any other questions to add to this mess? No? Okay, so let's do them. 2G. 2G. All right. Proofs. Proofs are fun. They can be frustrating, though. Sine of theta, that's the worst drawn theta ever in my life, plus cos of theta squared equals 2 sine theta cos theta plus 1. Well, that one's pretty crazy looking, hey? This is 2G, page 202. You know what's funny is I think, yeah, I'm just going to show you quick. Is this 2 sine theta cos theta? 2 sine theta cos theta. This is a proof that we're going to be adding to this, but we're not there yet, so can't use it. Well, you can, but I don't think it'll help you, to be honest. Okay, so there's a whole lot of craziness here. What I'm going to do is I'm first going to square this. That's just what jumps out at me. I'm going to square that. So this becomes sine times sine is sine squared theta. Sine times cos is sine theta cos theta, and then cos times theta, so it's going to do this. This is a regular kind of first outside, inside, last thing that I'm kind of skipping a step with. Cos squared theta. Any problem with that so far? Oh, look, this is actually turns out to be really easy. You probably love it when I say things like, this looks actually pretty easy. So all I did is I just squared this. Sine squared of theta plus cos squared of theta equals 1. That's one of our... I should just keep this paper off my board. Sine squared of theta plus cos squared of theta equals 1. This is one of the first ones that we did. So we have 2 sine theta cos theta plus 1 equals Is it clear what I did here?
Yeah, it's good.
You good? Who wanted this one? Was this you, Sam?
Yeah.
And you're good with that?
Yes.
Anybody else
Makes
issues?
sense now.
Anybody else questions before we move on? All right. Whoopsie. Just knocked everything over. Everything, meaning 2 pieces of paper. Next question, 3C. Identify the values of the variables in question 2 above. Oh, they're all listed here anyway. For which identity is undefined. Okay, so we're just looking for undefined between 0 and 2 pi. So just kind of once around the circle. Notice, not including 2 pi. There's not an equal sign there. So, and you'll sometimes be caught on this. Sometimes there's questions like this. I'm honestly a little bit surprised that I caught it myself right now. I often miss things like that. So this is 3C from page 203. ABC. Okay, so cos squared theta times cotan squared theta plus 1 equals cotan squared theta. All right, so all we're worried about right now are the non-permissibles. I can kind of ignore this cos of theta, but it's these cotans. Cotan is cos of theta over sine of theta. That's cotan. So wherever sine of theta is 0, that makes it non-permissible. So in our unit circle, this right here is x is 1, y is 0. So this one counts. Up here, this is x is 0, y is 1. That one's fine. This one, x is negative 1, y is 0. Another answer down here, 1, 0. So these are the 2 places. It has to be within, it can include 0, can't include 2 pi. So it's going to include 0. So sine of theta cannot equal, and if we're in radians, cannot equal 0 radians or pi radians. 2 pi, if this was an equal sign here, we would also have 2 pi there. Does that make sense?
The back of the book says that cos of theta can't equal 0. And so theta can't equal pi over 2 or 3 pi over 2.
Why can't cos? Oh, dummy. Okay, yeah, obviously. You know why? Because cotan of theta equals 1 over tan of theta, which equals 1 over sine of theta over cos of theta. So you're right. Yep, thank you for pointing that out. Anywhere you have anything in a denominator, so yeah, so you can't have it up here or here either. Thank you, Matthew. Pi over 2, 3 pi over 2. See, this is what happens when you rush. Slow down. Who can I blame? Thank you for that. Anybody have other questions or other places they want to point out my poor teaching?
But then it would just be cos, like, can't equal pi over 2, right? Not the sine stuff.
Okay, when I said don't point out my poor teaching, but yeah, you're right.
So the sine one does count as well?
Yep, both do.
Okay.
So theta cannot equal 0, pi over 2, pi, or 3 pi over 2. Sorry, what did somebody say?
The back of the book doesn't say that sine can't equal 0.
That's wrong. And you guys can see that's wrong, right? Like, anytime, anywhere, it's in the bottom. I need to open my door. I'm going to melt. Anywhere that it ever shows a fraction, the bottom of the fraction, anywhere it's possible, it cannot be 0. Are we okay with that?
Mm-hmm.
Yep.
So move on to H. Oh, that's a complicated one, hey? All right. (3H), page 203. So we have 1 plus tan of theta over 1 plus cotan of theta. So how did the answer show? It shows like what, like sine or cos can't equal, or is it showing what theta can't equal?
Both.
Okay, all right. So here it's because of our knowledge of what we just did with 3C, anywhere. Oh no, it's a little bit different because cotan is on the bottom. Yeah. Okay, so tan of theta, if we just look at the right-hand side for 1 sec, tan of theta, right-hand side, tan of theta equals sine of theta over cos of theta. So anywhere cos of theta is 0, which is at 90 and 270. So, or are we in radians? Yeah, we're in radians. So it's pi over 2, cannot equal pi over 2 and 3 pi over 2. That's because that's where cos is 0. Now, so I'll just circle that because that's one spot. Now let's look at this cotan of theta. It's tricky because it's cotan of theta, but it's also the 1. Because 1 plus cotan of theta, that is the denominator, that can't equal 0. So wherever it does equal 0 is a problem. And so to figure that out, we can just say cotan of theta equals negative 1. Cotan of theta is cos of theta over sine of theta. If that equals negative 1, so where does this equal negative 1? Tan is negative over here and over here. And to get 1, it's our kind of our 45-degree angles. So in pi, it's over 4, so that's 1, 2, 3. So this is 3 pi over 4, and 4, 5, 6, 7, and 7 pi over 4. So it cannot equal these ones as well as the other places that, because it's this is a fraction as well, this one can't equal 0 as well. So we have theta cannot equal pi over 2, 3 pi over 2. We've added these ones here. Theta can't equal 3 pi over 4 and 7 pi over 4. It also cannot equal, and you would put this just in one kind of line, anywhere where sine of theta equals 0. So that is at 0 and pi.
Is the sine still being affected by the -1?
No, because so what I did here, so this is in the denominator. We looked at this as a whole, but then we just kind of pulled out just the cotan itself. Cotan of theta equals cos of theta over sine of theta. So just even in this little tinier microcosm, we have a fraction here that will not make sense. Doesn't matter if it's +1, -1, or anything. As soon as you have a 0 down here, this is undefined. So not only can you not have 0 in the denominator, but this itself cannot equal -1, because when you add -1 to +1, you get 0 in this denominator. You know, it feels like we're kind of zooming in some like conspiracy theory film and every little tiny detail. Does that make sense?
Yes.
So basically it's anywhere you have a fraction, you cannot have a denominator of 0, even if it's for a moment. Like cotan, the way my brain works, it's like this for a moment. That's long enough, as long as there has that possibility. Tan of theta is only sine of theta over cos of theta. So if you have a question where you're focused on the tan of theta, sine can be 0, cos can't. But then it's like, oh wait, cotan is in the picture, then neither one can be 0.
So then what about for like 3b, where the -1 is outside of the fraction?
Then that doesn't affect it. All you're worried about there, sine in b, which is 1 minus sine squared theta over 1 minus sine of theta, and then -1. So this is totally unrelated to the fraction, so who cares? In all honesty, it doesn't matter. You can ignore them. Sine of theta is not a fraction. Ignore all of that. Focus on this. Sine of theta cannot equal 1. 1 minus 1 is 0. That's your problem. So wherever sine of theta, so the only place is 90 degrees, or pi over 2. That's the only one that's non-permissible for this.
Okay.
Okay, does that make sense?
Yes.
Anybody else?
For 2h, how would you expand that? Like, how would you expand the cotangent with the +1 there?
Okay, let's do it. Ones like that are tricky because you kind of have to. You're doing more steps, and you are what's the word I'm looking for? Simplifying. You're adding fractions. You're combining fractions. Is what that looks is going to happen. So 2h, page 202. 1 plus tan of theta over 1 plus cotan of theta. This is a proof. Okay, equals tan of theta. So the right-hand side, pretty straightforward. And you can think of it as sine of theta over cos of theta, because that might be what this turns out to be. So keep that in the back of your head, but this is clearly the one that needs the work. So the top, 1 plus sine of theta over cos of theta. That's the top, over 1 plus cos of theta over sine of theta. What we need to do here is we need to get common denominators so we can add the 1 to this. So to do that, on the top, I'm going to multiply it by this 1 by cos of theta over cos of theta. And the bottom is going to be, I'm going to multiply this, just the 1, by sine of theta over sine of theta. So what that becomes is cos of theta plus sine of theta over cos of theta. That's on the top. And the bottom is sine of theta plus cos of theta over sine of theta. Are you with me still?
Yeah.
So now we flip and multiply. Cos of theta plus sine of theta over cos of theta. I need to slow down and write neater. Over sine of theta. See where this is going?
Mm-hmm.
Over sine of theta plus cos of theta. Well, these bad boys can cancel. And we're left with sine over cos.
Okay.
It's tricky. Like to go from this to this is the most important part.
Yeah.
It's just finding common denominators you can add. Great question. See, and this is what makes me nerdy because I love. I just about almost swore. This is fun for me. This stuff is seeing things go complicated and then come down to be nice and clear.
Yeah.
I have a question about that. What you did.
Yep.
For when you multiplied the top by like cos of theta over cos of theta.
Yep.
Wouldn't like cos of theta over cos of theta times by sine of theta over cos of theta, wouldn't that equal like cos of theta times sine of theta over cos of theta? Or,
sorry, you know what? That's a fair question. I have these brackets here to show that this is the numerator and this is the denominator. There aren't actually brackets when I multiply. Like if I want to write this out clearer, it would be cos of theta over cos of theta times 1 plus sine of theta over cos of theta. So this is my numerator. This is just what's on top. And then I've got what's on the bottom. So I'm just multiplying by the other one, not the whole numerator. Thank you for asking. You guys, these are great questions. Great questions. I'll never get upset with you for asking questions. If you remember my promise from grade 8, if I ever give you grief for asking questions, you can throw something at me. Although you can't because this is remote, so ha ha ha. But I won't do it anyway. Any other questions? Anything else you want me to go over? That's it then. Now, also, one other tiny thing I'm going to mention just while you guys are here. We, partially because of this, the way this textbook works, it's been pretty nice. It's very efficient. It is quite normal to have a couple hours of pre-cal homework most nights. That is quite normal. This year has been abnormal for a billion reasons. But every once in a while, especially when you're doing these proofs and if you're struggling a bit, you might be doing work for a couple hours. That's a little bit of the nature of this animal. So don't think that you're dumb or try not to get frustrated. I know it's nice when you have 10 or 15 minutes of homework and then you just go do whatever you want to do. But every once in a while, there will be a fair amount of homework. And we've avoided that largely. But these proofs, these can be wrestling matches for sure. Any other questions? I get the impression people are waiting for a question, like because maybe they have one, or maybe they just don't want to miss out on something, because everybody's still hanging out.
Usually, if we're in class and you say that kind of stuff, then we just kind of like shake our heads or something.
Yeah, it's true.
Really do
yeah,
that here.
That's true. But it's a not a red flag. It's my teacher. Brain is just reading the fact that everybody's still hanging around. It's it's not like people aren't just boop, 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 dropping out. So if you're hanging around, it makes me think there's something else somebody needs. Maybe not.
Because we love hanging with you, Mr. Morris.
It could be that. I was just gonna say it could be just that like with the lack of connection with everybody, it could be we're just hanging. All right. Well, then I'm going to be the one to end this meeting. If you have any other questions as you're going through, or if for whatever reason there's something that you didn't want to say in the group, then you can email me or text me or see me in person. And there we're starting to drop. Okay, we'll see you guys. Take care.
Goodbye.